Moving on to question type number 2. It says launched at an angle on level ground. A projectile is launched from flat, level ground, so they're really emphasizing that, at 18 meters per second at an angle of 40 degrees above the horizontal. So, quick picture, flat level ground, shot at 18 meters per second at an angle above the horizontal. So I'm going to start at my flat level ground and I'm going to go above horizontal by 40 degrees. What is its maximum height? So I'm going to do a little boop, boop, boop. It's asking, at this moment, what is h? Well, h is the same concept as dy as far as matching up variables in our equation. So I'm trying to find dy specifically at this moment. Now, what do I know about that moment? At this moment, Vy is equal to 0 meters per second. So I know that, that's good. What else could I know about this? Well, in this triangle, 18 meters per second is my hypotenuse, but V initial y is going to be 18 times the sine of 40 degrees, and V initial x is going to be 18 times the cosine of 40 degrees. Let me just calculate that real quick. 18, 40. Okay. So I know my V initial y, and I know my final y if I call this, the end of the situation that I'm focusing on. So I'm going to call this my start, and I'm going to call this my end. And I'm going to focus on the y direction because I know good information about the y direction. So I know Vf. Oh boy. I know Vf in my y direction. I know Vi in my y direction. I know A in my y direction. And I want to know dy. To me, that looks like Vf squared equals Vi squared plus 2AD. Alright, so that's my maximum height because it's my y displacement at the moment when Vy was 0. So that's my maximum height moment. A tip to be aware of, oftentimes students will forget either this negative sign or they'll do something silly and maybe put a negative sign here or something like that. If you got a negative distance on the way up, that should inform you that, oops, somewhere in here I was loose with a negative sign. So you can always think about, okay, at the beginning, was it moving up? Yes, so positive. At the beginning, was gravity pulling it down? Yes, gravity is always pulling it down, regardless of whether it's moving up or down. Okay. Okay, so then part B, what is the total flight time until it returns to level ground? There's two ways that I could do this. One way would be to analyze from this end to this end, just beginning to end, the total time. Another way that I could do it is I could compare this beginning moment with the end And then because it's symmetrical, only because it's symmetrical, would I then be able to say, well, this time is equal to this time, so I can just multiply by 2 to get my final answer. And that's what I'm going to do, because the math is usually simpler in order to do that than it is to do the full time. The other one typically involves solving a quadratic, which just isn't my jam. Yeah, it would work. Yeah, we could do it. Let's just do it. All right, so I'm going to analyze end to end. So for part B, dy equals v initial y times t plus 1/2 ayt squared. 0 is my vertical displacement because I started and ended at the same height. And then my v initial y is 11.57 times t plus 1/2 times negative 9.8 times t squared. Here's where the math would be bad and it'd be quadratic, but it becomes easier because it's set equal to 0. If I factor out a t, I've got 11.57 plus negative 4.9 t equals 0. One solution to this problem is that t equals 0. The other solution to this problem is that 0 is equal to 11.57 minus 4.9t, negative 11.57. .36. Cool. Now I have to remember not to do like blindly just multiply things by 2. Because I chose dy as 0, I was choosing these two locations where they end at the same height. So that's already my whole picture. So that's my final answer. That is t total. Lastly, it says, what is the horizontal range? What that's ultimately asking about is dx. So let's see, dx is equal to v initial x times t plus 1/2 axt squared. Ax is going to be 0 because gravity and nothing's pulling it sideways while it's in the air. So dx is equal to 13.7, which I got from our previous 18 cosine of 40, times 2.36 dx. Whoops. 13.7, 32.34. Cool. And that's how you do angled launch on level ground specifically. All right. Finished with question type number 2.